Hello students, we will start the second unit of automata theory, that is finite automata. So we already seen the concept of automata. Automata means what? It is a self-propelled, automatic or self-controlled machine or model. And here the word finite means what? These automata or automatic machine we will going to design using finite number of states, finite number of inputs. Okay, finite transactions will be there. So it is named as finite automata. So for draw and very important, it is a graphical technique or graphical method. That is, we will draw this model using a diagram, graphical method. Second thing, it is a way of defining a language. It is way of defining a language. What is this method of defining a language? So as to require preliminaries required for this graphical method or DFA, we already learned that is what is alphabets, input alphabets, symbols, language. These terms we already seen in the first chapter. So here we'll focus on the finite automata, how to draw the finite automata, what are the types of finite automata, etc. So for this finite automata, it is language defining method. Here graphical tools are used. Here, so we can say the model, we will show the model of this finite automata. See, we can say it is like a input tape is there, okay, which will accept one letter at a time, one letter or one alphabet at a time. And we can say one of the finite control is there, finite control. This is a tape reader. See, as one by one symbols comes A, B, B, A, like this. This input, this finite control reads one input symbol from this one cell. One cell at a time store only one alphabet here. So as a tape reader goes ahead, that means what? While it reads to a first symbol, the tape goes to second cell. It reads third, fourth, like this. At a time, one symbol is read at a time. This is the one model of this FA, finite automata. Okay. As we have said, it's a language defining method. So very important is that it requires to accept a, or it accepts a pattern of language. We'll see it later. Okay. So this is the overall model of the FA. Then we'll see what are the components required to draw this FA. So we'll see the component or tuples. Tuples or set which requires C for this FA. To define this finite automata, we require a set of things, that is that components are called as a tuple. So 5 tuples are required. See, set of 5 tuple Q. We will see one by one what is the meaning of its Q. Then this is summation, delta. It is referred as delta, Q0 and F. See one by one. So here Q is, okay, see Q is finite set of states. Okay, so we can use here Q0, Q1, Q3 like this. So Q is finite set of states. So states are defined the set of, it is defined the set of states. It contains ready state and dead state, final state. Next is summation. It is finite set of input symbol. Finite set of input symbol. This, so before delta we will see Q0. Q0 is initial state, the state from where we start the FA, that is initial Q0. Okay, as initial state is there, we should stop that FA, that is final state. It is F is a final state. Okay, and very important is delta. Delta is a transition function. Transition function. See, this delta brings the transition from initial state to final. So goes from initial to final, there may be number of states. So delta changes the states after accepting a input. We will give the input, then state changes. The state change is called as a transition. Okay, state change is called transition. These 5 tuples are very important. Remember these 5 tuples. The question is asked in exam. How many tuples are there? Or explain the tuples of FA. So Q is the finite set of states. Summation is input symbol. Q0 is initial state. F for final state, and transition function, that is a delta, which brings from initial state to final state. Thank you.